And
I'm still recording. I'm not pushing any buttons. It's still recording. Just go.
oh, and I'm Jeff.
I'll just smash cut it.
Hi, I'm Anders. Hi, I'm Eric.
Some stone paste.
I can do it. I can do goofier if you want me to.
No.
The entirety of our coffeehouse discussions were on the matter of intelligence, what it was, and how to test for it.
The results were inconclusive.
But we made several interesting discoveries.
As we discussed in class, the Turing test is not a sufficient test for intelligence because it can be spoofed into giving a false positive, namely like the Chinese room test.
The conclusion of the Chinese room experiment that we discussed in class is that a program of an if-then tree that is sufficiently complex can produce the same level of cognition as a human being through simple input and output.
The problem with this model is that it gives the exact same output for a given input, much like a finite state autonomy. We believe that a necessary quality of an intelligent being is the ability to alter its response to a given input, thus changing its behavior.
The Chinese room passes the Turing test because the person outside the room thinks that they're having a conversation with a native Chinese speaker, but because the Chinese room isn't actually intelligent, the Turing test is insufficient. We need a new Turing test.
The definition of intelligence is the action or fact of mentally apprehending something. Understanding, knowledge, and comprehension.
When it comes to artificial intelligence, we believe that not every program which takes an input and returns an output is intelligent.
A finite state automaton
It's not intelligent because it responds exactly the same way to a certain input every single time, much like the Chinese room that we discussed earlier.
On the other hand, because the Turing machine can alter its programming, it seems to be the lowest embodiment of intelligence.
The earlier definition of knowledge is a
Old definition from the Oxford English Dictionary. So as far as cognitive science and artificial intelligence goes, your mileage may vary.
But at the time that definition was written, it was thought that only people exhibited intelligence. But is that true? Does a dog exhibit intelligence? How about a worm?
If mimicking human behavior is not a useful metric for defining intelligence, what does that mean for other creatures?
Some people believe that intelligence is binary, that you either exhibit it or you do not. We believe that many organisms exhibit intelligence to varying degrees.
Because there are many levels of intelligence, there are some that are simple enough to be represented by a simple neural network achievable by today's standards. Take, for example, a worm, which has 302 neurons and 6,400 synapses.
Our digital copy of the worm is going to be exactly as intelligent as the real thing.
If we can simulate a biological worm using a program, then we have created an intelligent program. And this concept scales up as far as you want, all the way up to humans if you wish.
Any test which you could reasonably expect the biological being to pass, the virtual copy would pass as well.
This demonstrates that intelligence is platform independent.
People like Turing seem to have been testing for something other than intelligence as we've defined it. They seem to have been testing for personhood or moral relevance.
A being can be intelligent, like the worm, but that doesn't necessarily mean that that being is a moral subject.
A moral subject is something that can be harmed. You could harm a dog, but you couldn't harm something like Google Maps. A moral actor is something that can differentiate between right and wrong and also be held accountable for its actions.
The Turing test is not an adequate way to determine whether or not a being is a moral actor or a moral subject. If you took the man out of the Chinese room and you burnt the Chinese room down, you wouldn't feel sorry for the Chinese room. In conclusion, the Turing test is insufficient, and we need a new test of intelligence.
Here's an example of why. We could have a chimpanzee and a program that simulates a chimpanzee, and both would be considered intelligent by our earlier argument. Yet both would fail a Turing test.
The guiding principle for this new intelligence test must be that it not yield false positive results.
But we cannot possibly guard against false negatives because an intelligent being could
Be lying to the test, be playing a game.
Or have a level of intelligence lower than that which is being tested.
While we cannot presently conceive of such a test, a successful intelligence test will need to be flexible enough to adapt to future notions of intelligence, unlike our old friend the Turing test.
No one cares about your robot fan fiction. Don't give a about no robots. They ain't got no soul.
Are you still recording?
I am recording.
Oh, okay.